Okay, hello everyone. So in current electricity, we have already covered resistance, Ohm's law, drift velocity, current density. Now moving forward, there are very important derivations in current electricity for our board exams. Also, this derivations and the formulas are also important for your MCQs part. So what you have to do is you have to write down all these derivations because you can expect at least one derivation from what I am teaching today. So let's move forward. So first, let us discuss what we have already read. Like we have already derived Ohm's law, that is V is equal to I into R. So V is potential difference, I is current in the wire, and R is resistance. Similarly, current will only flow if there is electric field in a wire, and potential difference is also equal to electric field into length. This formula we have already derived. So V equal to IR, so potential difference is I into R. Similarly, potential difference can be equal to E into L also. And also we have derived formula for resistance. So resistance is resistivity into length of wire divided by area of cross section. Okay, so you have to remember all these formulas. Similarly, we have derived the formula for drift velocity. See, drift velocity is minus into E, that is charge of electron, capital E, that is electric field, tau, that is relaxation time, divided by m, that is mass of electron. So to remember this formula of drift velocity, that is minus E tau by m. Similarly, formula for current, that also we have derived. Current is equal to area of cross section into this n is number of electrons per unit volume. Okay, this n is not total number of electrons. N is number of electrons per unit volume. E minus is charge of electron and Vd is drift velocity. So you have to remember all these important formulas, the five formulas that are mentioned in this slide for resistance, for potential difference in current, for potential difference in electric field, for drift velocity, and for relation between current and drift velocity. Okay, now moving forward. Okay, there is one very important topic, that is current density. Remember that current density is a vector quantity and it is denoted by J, and J is given by I by A. So I is basically current, A is area of cross section. So to remember that this current density, it is a vector quantity. This is a vector quantity and its SI unit will be, we'll see, it will be ampere divided by meter square, because I is ampere, area is given by meter square. So to remember the formula for current density, you have to remember that it is a vector quantity and you have to also remember the SI unit of J. Now we know that V is equal to IR by Ohm's law, V equal to E into L. These two formulas we already derived. So since the left hand side are equal, so right hand side will also be equal. So E into L will be equal to I into, and formula for resistance is rho L by A. So L and L will get cancelled out and I by A is current density. So electric field is equal to current density into resistivity. This is a very important relation between electric field and current density. And remember that electric field and current density are parallel to each other. So both of them will be in same direction. Also, there's an important parameter, that is conductivity. So sigma is conductivity and it is equal to 1 upon rho, and rho is resistivity, sigma here is conductivity. So you have to remember all this important relations. I'm again telling this, all relations are very important. See, we have already derived that E equal to 0, putting value of J to be I by A and putting value of I to be A and E V D. A and A will get cancelled out. If you'll see, if we'll put the formula of drift velocity, that is minus E tau by M, this minus and minus will get cancelled out and this electric field and electric field will get cancelled out. Now by cross multiplication, formula for resistivity comes out to be M divided by N E squared tau. Similarly, conductivity is 1 by resistivity. So conductivity will be reciprocal of resistivity. So conductivity will be N E square tau by M. Now if we look directly at the formulas, then resistivity is directly proportional to mass of electron. And it should be, because more the mass, more the inertia, more the problem will be in moving the electron. So more the mass, more will be the resistivity. Similarly, resistivity is inversely proportional to number of electrons per unit volume. See, if n is higher, it means number of electrons are more. So if n is higher, then resistivity will be less. Similarly, it will also depend on tau. So the less the value of tau, the more the value of resistivity, or we can say the more the value of tau. So if tau is more, it means the relaxation time is much more. it means electrons are moving more freely. It means there are lesser number of collisions. So if there are lesser number of collisions, then resistivity will be less. So if tau is more, then resistivity will be less. Similarly, uh, using all the same principle, conductivity depends on n. More than, more will be the conductivity, more tau, more will be the conductivity, and more the mass, less will be the conductivity. So you need to remember the formula for resistivity and for conductivity. These formulas are very important when solving conceptual questions. Okay, now there is one more very important parameter called as mobility. So mobility is drift velocity per unit electric field applied. So what is the meaning of mobility? So the value of mobility tells you how easily a charge can move when electric field is applied. So if you apply electric field and if there are two charges. Now my question is, which charge will move more easily? So basically you will see at the value of mass and the value of charge. So basically mobility is drift velocity divided by electric field. E and E will get cancelled out, so mobility will be minus E tau by m. We are only concerned about the value of mobility. So basically mobility will be equal to E tau by m. If you'll see, mobility is directly proportional to charge. The more the charge, the more the force on it will be, and it will, it will move easily. Similarly, the more the tau is more, it means relaxation time is more, it means collisions are less, so that charges are moving freely. And similarly, lesser the mass, more will be the mobility. Because if mass will be less, then inertia will be less and mobility will be more. So mobility depends on charge, relaxation time, and mass. This m is mass of electron. So you can calculate mobility for any mass, for any charge. You just have to put the value of charge, tau, and mass of that charge. Also remember, the SI unit of mobility will be, its velocity is meter by second, electric field is Newton upon Coulomb. So you have to remember the SI unit of mobility also. Okay, now on the basis of this lecture, you have to submit an online quiz. Okay, and if you have any doubt in that quiz, please WhatsApp me. The link to the quiz will be given in the description below, and also you will receive the message of this video. Okay, have a great day. If you have any doubt, you can WhatsApp me.